The first thing you notice about Cédric Villani is that he is wearing the wrong century. He walks into a room and the year instantly becomes 1890. A lavishly bowed silk cravat circles his neck, complementing the three-piece suit and the ever-present pocket watch. And pinned to his lapel, glinting under the fluorescent lights of a television studio or a government hall, is a giant silver spider. He does not look like a man who solves partial differential equations for a living. He looks like a magician who has just arrived to saw a woman in half, or perhaps a vampire who has decided to try his hand at public policy. A true anomaly in his field, Cédric Villani bucks the trend of the typically invisible mathematical genius. Known as the Lady Gaga of mathematics and the Spider-Man of the Sorbonne, Villani is arguably the most charismatic mathematician alive, and certainly the most famous Fields Medalist. Most mathematicians live inside their heads. They live in a world of pure abstraction, a place where the messy, loud, and stupid noise of the real world cannot touch them. They build castles out of logic and pull up the drawbridge. Villani did the opposite. He decided that the only way to save mathematics from obscurity was to turn discussions into something the world can't ignore. He spent the first half of his life proving that chaotic systems, like a cloud of gas or a plasma storm, have a natural tendency to settle down into order. He proved that if you wait long enough, the chaos organizes itself. Then he spent the second half of his working as a member of the French Parliament, running for mayor of Paris, creating France's national strategy for artificial intelligence, becoming a best-selling author, a TED speaker on the topic, "What's so sexy about math?" and using music to teach individuals with disabilities like autism. This is the story of a man who conquered the highest peak of mathematics, winning the Fields Medal in 2010, considered the Nobel Prize of Mathematics. Only harder to get because you have to be under 40 to win it. Having won it, he looked around and decided it was too lonely. He is a genius who decided that being right was not enough. He wanted to be heard. The genius of Cédric Villani came from pain. It comes from a feeling of alienation, a sense that the human world is a strange and unpredictable place where people say things they do not mean and do things for reasons they do not understand. For a child who feels this way, mathematics was a rescue boat. Villani was born in 1973 in the south of France. He was not a prodigy but someone quieter. He was a boy drowning in words. His parents were both literature professors. Being physically fragile and really shy, he didn't say anything and just sat in the back of the classroom. He read novels like a starving man eats bread. But somewhere around the age of 13, he found something better than stories. He found geometry. It was the first time in his life that he encountered a system where he could be absolutely 100% sure of something. He began to keep notebooks. He filled them with axioms and theorems. France has a very specific way of dealing with people like Villani. In the United States, a kid who is good at math might get a pat on the head and a job at a hedge fund. In France, mathematics is a national sport. It is a matter of pride. The French system is designed to find these brains, polish them, and turn them into the intellectual elite of the Republic. They have a pipeline. It starts with the intense classes préparatoires, or prépa, a 2-year academic boot camp designed to break your spirit. If you survive that, you go to the grandes écoles. Villani did not just survive, he thrived. He entered the École Normale Supérieure in Paris, the Hogwarts for French geniuses. This is where the transformation happened. You might expect that a shy, bookish boy entering a pressure cooker of competition would retreat further into his shell. Villani went the other way. He became the president of the student union. He started wearing the suit, he started wearing the spider. He realized something that most smart people never figure out. He realized that if you are going to be weird, you should be weird on purpose. You should own it. You should turn your strangeness into armor. The spider brooch was not a random choice. Spiders weave webs. They make connections. Villani wanted to be the guy who connected things. He found a mentor named Pierre-Louis Lyons. Lyons was a giant in the field. He had won the Fields Medal himself. Lyons worked on partial differential equations. These are the equations that describe the physical world, how heat moves, how water flows, how gravity pulls. Villani looked at the work Lyons was doing and saw a landscape that was vast, difficult, and frighteningly complex. It was the study of kinetic theory. It was the study of how billions of tiny particles, like atoms in a gas, interact with each other. It was the study of chaos, and Villani decided that this was where he would live. To understand why Cédric Villani became famous, you have to understand the problem he solved. If you pour a distinct swirl of cream into a cup of black coffee, you can see the white streak clearly. But if you wait, or if you stir it, the white streak disappears. It mixes in. The cup becomes a uniform beige. The information about where the cream used to be is gone. The system has reached equilibrium. Physicists have known it happens since the 19th century, when a bearded Austrian genius named Ludwig Boltzmann wrote down the equations for it. But knowing something happens is not the same as proving why it happens. For more than a century, nobody could prove, with absolute mathematical rigor, exactly how fast a gas settles down into equilibrium. Nobody could prove that it always happens under all conditions. The equation Boltzmann wrote down was a beast. It was a non-linear monster. It described a system where every particle is banging into every other particle, a billion times a second. Villani looked at this mess and saw a challenge. He wanted to know how order emerges from disorder. He wanted to know the speed of forgetting. He teamed up with a collaborator named Clément Mouhot. They set their sights on a specific version of this problem involving plasmas. A plasma is a gas that is so hot that the electrons have been ripped off the atoms. It is a soup of charged particles. In the 1940s, a Soviet physicist named Lev Landau suggested something impossible. He said that if you disturb a plasma, if you send a wave through it, the wave will eventually die out. The plasma will calm down. That sounds normal, right? Waves die out in water because of friction. But Landau said this would happen in a plasma without any friction. He said the plasma would stabilize itself simply through the way the particles moved and reorganized. Physicists believed Landau was right, but only in a perfect, simplified world. They did not know if it was true in the real, messy, non-linear world where giant waves crash into each other. Villani and Mouhot decided to prove it. It was 2 years of grinding, miserable failure. Villani describes the process in his memoir, Birth of a Theorem, and it reads like a survival story. They hit walls. They found holes in their logic. They sent emails to each other at 3 a.m. that consisted of nothing but despair. At one point, Villani was ready to give up. The problem felt too hard. But he kept going. He used every tool in the mathematical toolbox. He invented new tools. He developed something called hypercoercivity, which is a way of measuring how a system is forced to calm down. It finally clicked. He'd actually proven Landau damping was real and showed that chaos has its limits. His research confirmed that even in super high-energy, frictionless systems, things eventually settle down. The plasma cools itself off. It was a monumental achievement. In 2010, the International Mathematical Union awarded him the Fields Medal. He had reached the summit at the age of 36. He was the best in the world. He could have stayed there. He could have spent the rest of his life in a comfortable office, solving problems that only 10 people on Earth understood. But Cédric Villani has never been good at sitting still. Most people who win the Fields Medal take the medal, put it on a shelf, and go back to work. Villani took the medal and went on tour. He realized that he had an opportunity. The medal gave him a platform. The suit gave him a brand. He could use them to do something that nobody else was doing. He could make mathematics cool. He started accepting invitations. He went on talk shows. He gave TED Talks. He wrote books. He did not dumb it down. That was his secret. He did not talk to the public like they were children. He talked to them like they were adults who just happened not to know the vocabulary yet. He used metaphors. He waved his arms. He talked about the eroticism of mathematics. He compared equations to music. He told stories about the great mathematicians of the past, turning them into tragic heroes and romantic adventurers. He became a sensation in France. People stopped him on the street and asked him about the spider. "Because the spider is the master of connections," he would say. Or sometimes he would just smile and say nothing, letting the mystery do the work for him. He was playing a character, yes, but the character was serving a purpose. He was trying to show people that math was not just about memorizing multiplication tables. It was about creativity. It was about passion. It was about seeing the invisible structures that hold the world together. As the director of the Institut Henri Poincaré in Paris, he successfully raised millions of euros. He utilized these funds to expand the building, transforming it into a vibrant global hub. This center allowed mathematicians from all corners of the world to convene and interact, mirroring the collision of particles described in his own equations. He firmly believed in the strength of the social web, recognizing that geniuses thrive not in isolation, but by working collaboratively in swarms. He was riding high. He was one of the most famous mathematicians globally, or at least the most recognizable one. He had cracked the celebrity code, showing that a nerd in a velvet suit could be a rock star. And then he made a mistake. He looked at the French government and thought, "I can fix that." In 2017, a young banker named Emmanuel Macron was running for president of France. Macron presented himself as a new type of leader, transcending the traditional left-right divide. He was a rationalist and a technocrat focused on bringing intelligent individuals into government to tackle challenges with evidence and logic. Villani looked at Macron and saw a kindred spirit. Here was a man who wanted to bring order to the chaos of politics. Villani decided to join the movement. It seemed like a perfect fit. Villani ran for a seat in the National Assembly. He campaigned in his three-piece suit. He walked through the markets of the Essonne region, shaking hands, explaining his vision. The voters were charmed. They saw him as an outsider, untainted by the grime of professional politics. They elected him in a landslide. Suddenly, the man who spent his life thinking about the Boltzmann equation was sitting in a parliamentary seat, listening to debates about zoning laws and pension reform. The government put him to work immediately. They gave him a massive task. They asked him to write the National Strategy for Artificial Intelligence. This was Villani's moment. This was exactly why he had come. AI is a mathematical problem. It is about algorithms, probability, and optimization. It is about the future. Villani dove into the work with the same intensity he had applied to the Landau damping problem. He gathered experts. He interviewed hundreds of people. He worked late into the night. He produced a report called AI for Humanity. It was brilliant and comprehensive. It laid out a plan for how France could compete with America and China without losing its soul. The document was a technocratic masterpiece, focusing on ethical considerations and leveraging AI to genuinely assist people, rather than simply maximizing revenue. But then came the hard part. In mathematics, once you prove a theorem, it stays proven. It is true forever. You write it down, you publish it, and the argument is over. Everyone agrees. In politics, the argument is never over. Villani discovered a world resistant to logic. Even with the most sophisticated data and elegant proof, a plan could be dismissed if it faced union disapproval, became a political target for the opposition, or simply encountered a negative public mood. Villani tried to bring the scientific method to the parliament floor. He became the president of the Parliamentary Office for Scientific and Technological Assessment. He tried to get his colleagues to look at the evidence and explain that facts are not negotiable. He watched as his rational arguments bounced off the walls of the assembly hall. He watched as decisions were made based on emotion, on fear, on short-term tactical advantage. He was a man trying to play chess in a room where everyone else was playing dodgeball. The tension came to a head in 2020. The mayor's office of Paris was up for grabs. Villani decided he wanted the job. He had a vision for the city. He wanted to use data to fix the traffic, the pollution, and the housing crisis. But there was a problem. The president's party, the party Villani belonged to, had already picked a candidate. They picked a loyalist, a politician. After calculating his chances and assessing his opponent, Villani determined he was the superior option. Logically, he was the best fit for the role and should therefore prevail. Despite this, he proceeded with his campaign, challenging both the president and the authority of his own party. It was a disaster. The party kicked him out. The voters were confused. He split the centrist vote. He campaigned hard, walking the streets of Paris with his spider brooch, trying to explain his complex plans for urban optimization. But the voters did not want an algorithm. They wanted a politician. He lost, badly. Cédric Villani is no longer the golden boy of the French government. His parliamentary tenure ended in June 2022 after he lost his re-election bid for the Essonne's 5th constituency by a narrow margin of just 18 votes to the pro-Macron candidate, Paul Midi. You might look at his political career and call it a failure. You might say that he was naive, or that he should have stayed in his office at the Sorbonne, proving theorems that will last for eternity, instead of wasting his time in the mud. But that would be missing the point. Villani's life has always been about testing the boundaries of systems. He tested the boundary of gas dynamics. He tested the boundary of academic celebrity. And finally, he tested the boundary of democracy. Villani proved that a gas can forget its past. He proved that chaos can turn into order. He has not proven that politics can make sense. Not yet, but give him time. He is only 50 years old, and he still has the spider. There is a moment in Birth of a Theorem where Villani talks about the feeling of being stuck. He describes the darkness of the mind when the solution is just out of reach. He says you have to dwell in that darkness. You have to be comfortable with not knowing. You have to trust that if you keep pushing, if you keep thinking, the light will eventually turn on. Today, Villani remains highly active in the academic and public spheres following the end of his political tenure. He continues his work as a distinguished professor of mathematics at the University of Lyon and IHES. He travels extensively, delivering public lectures and participating in conferences globally, promoting mathematics and science communication. He is also focused on his writing, sharing his unique perspective on the intersection of science, ethics, and society with a wider audience. He changed the way we see mathematics. He took it out of the basement and put it on the cover of the New Yorker. He showed us that logic can be stylish. Maybe one day we will be ready for it.